This is the steering stand on a bridge autopilot. What is autopilot system? I already explained about this is a steering system. Nowadays, on board ship we are used in a automatic steering system so that they can take out manpower, and without manpower we can run the ship. We can move the ship. So this is the inside ship how the autopilot can work. Here is the helmsman, he is moving his steering and moving the ship. Modern control theory and autopilot system. Here the controller, actuator and ship. This is the autopilot. Autopilot, and this is the steering gear system, and this is the ship. Here it will be connected to the Gyrocompass, and here given the course and deviation. This is only the mathematical model of autopilot system. Next. This is the block diagram of our autopilot system. Here autopilot has connected in a bridge wheel, so that this is a full pole-off controller, and this is the, here we can see the steering system. Autopilot here full pole-off is connected, and autopilot there is a both system. This is actually the complete block diagram of the autopilot system, how it works. Here local control unit has to be connected, and here the power supply has to be given to the local motor control unit. Here this is the sump, and the motor is to be connected into the this windings, and this is the solenoid valves. Rudder stop has to be connected here, and this is the cylinder has to be connected to both sides and port side and starboard, and the rudder angle feedback has to be given, and here also rudder has to be given. What is the rudder stop? Rudder is the one who connected in a propeller so that we can turn the ship. Only 35 degree we can turn the ship in a port side and starboard side. 35 degree so that it start as a starter, and the rudder stop has to be connected here so that we can easily move the autopilot. Here autopilot system working. Turning a wheel processing potentiometer. Turning a wheel processing potentiometer in a balanced bridge network, the unbalanced the electrical circuit. The error signal activates an intermediate power servo that supplies the local control unit and moves a potentiometer linked to the rudder. Rudder already I have explained to the where it should be connected, and near to the connected by the cylinder, and feedback has to be given. The balance is the circuit once again and cut off the servo when the helm and relative servo angle positions neutralize each other. The power servo is in most cases a rotary electro-hydraulic unit that can be linked to a miniature steering gear. It is designed for the application with the any steering gears variant, and servo has one link, has a chain of servo mechanisms from the wheel to the rudder. Electro-hydraulic control has many variants. Like twin ram system is the most common in the onboard ship. We can use in autopilot system. This is the picture shows the modern autopilot system. This method may use in a microprocessor based circuit to receive the helm order and the rudder position feedback and compare them. Rudder feedback position already connected to the starboard and the starboard, and the autopilot model 1500 is one example. The other case is the operation of the amplifier could be used instead. And the mechanical linkages and the differential controls are replaced by quick response. Quick response for the electronic servo, control valves for the hydraulic pump, for the hydraulic pump, which receives the order from the microprocessor to stroke the pump in the direction and the degree requested. And for the variant, this is the system where the electronic signals from the controller and the feedback device to be compared, amplified by the power amplifier, whose output controls the solenoids and the electro-hydraulic unit. The electro-hydraulic unit serves as an interface interface between the computing circuit and the hydraulically operated trams. It directs the hydraulic pressure to the cylinder. This is how the autopilot works. When we give to the pressure to the autopilot system. This is the Gyrocompass. Gyrocompass is the master compass used in an onboard ship. The triple students has to be actually when they can easily understand what is the gyrocompass used in an onboard ship. But the students can be understand easily what is the use of gyrocompass, where it will be actually located. And what is the use of gyrocompass used in a bridge side? See, this is the gyrocompass. First of all, the navigation instruments uses today. The master compass. Master compass is a gyrocompass. It's the oldest and probably that most navigators feel happiest with the gyrocompass. However, even the humble compass has not escaped with the advance of the microelectronics. So, this is one of the navigation systems so that the seafarers can easily navigate the system. All the modern gyrocompass are computerized. Nowadays, the most advanced technologies are coming so that modern gyrocompass also can use principles upon which they work remain unchanged. Next. Here, the first not in practical from the Gyrocompass was patented in 1885 by the mariners Gordon and his scientist named usable Gyrocompass was invented in 1906. In the German by this is another scientist named Hermann Kampfe, and after successful test of 1908 became widely used in German Imperial Navy. The gyrocompass was an important invention of nautical navigation because it allowed accurate determination of a vessel's location. Now you have to understand what is the use of gyrocompass in navigation system. Navigation system in a nautical field, this gyrocompass, why it is used? Because it is allowed to accurate determination of the vessel's location at all the times. So regardless of the vessel's motion and whether and amount of the steel used in the construction of the ship. So most purpose of using this gyrocompass to find the determination of the vessel's location and also the times that weather condition, and this is the one of the most uses of gyrocompass we have studied. Next, this is the one cross section of the gyrocompass, how it looks. This is the gyrocompass repeater. See, gyrocompass is the master compass that I have shown in before, so that it is only used in a navigation part. This is the gyro repeater we can use in many locations in an onboard ship, so that in the engine side and in the steering side and in many locations we can use this gyro repeater. But the gyrocompass is a different compass. This is master compass used only in a bridge. This is the free gyroscope, how it balanced. There will be a axis start, spin axis, spinner and balance splitter here. Platform vertical pivot horizontal. This is a reproduced courtesy of probability. This is a free gyroscope. This is a picture how it will be moves. Come to the gyrocompass gyroscopic principle. Gyrocompass works on the principle of gyroscopic and at the heart of the marine gyrocompass assembled in a model gyroscope. Gyrocompass is works on the principle of gyroscope. At the heart of the marine gyrocompass assembling a modern gyroscope consists of perfectly balanced wheel. Arranged to spin symmetrically at high speed about an axis or axle. The wheel or rotor, here the wheel or rotor spins about its own axis and suspending the mass efficiently designed gearbox assembly. The unit is free to move in two places, each at right angles to the plane of the spinner. This is what I have shown in a picture that how it like spin axis, and here the right axis to the plane state. There are therefore three axes which is gyroscope is free to move as illustrated in the figure. This is what I have shown in the figure: the spin axis and the horizontal axis and the vertical axis. In a free gyroscope, none of the three freedoms are restricted in any way. Three, that is called spin and horizontal vertical. In such a gyroscope is almost universally used in the construction of a marine gyrocompass mechanisms. To other types of gyroscope, the constraint and the spring restriction are now rarely seen. This is what this is the three axis. One is spin axis and the vertical axis and the horizontal axis. It moves. We have to remember most. Yes, in order to understand the basic operation of the free gyroscope. Now it's the time to understand how the free gyroscope works. In order to understand the basic operation of the free gyroscope, reference must be made to some of the first principles of physics. The free gyroscope possesses certain inherent properties, one of which is inertia phenomena. We already know, so we already studied about the phenomena that can be directly related. One of the basic laws of motion documented by Sir Isaac Newton. Newton's first law of motion states that a body will remain in the state of rest or uniform motion in a straight line unless force is applied to change that state. Therefore, a spinning mass will remain its plane to rotation unless acted upon by the external force. Here we can easily understand the basic operation of the free gyroscope. Actually, the Newton's first law, here Isaac Newton's first law, we are used to this phenomena is used in a free gyroscope. A body will remain in its state of rest or uniform motion in a straight line unless a force is applied to change the state. I'm talking with the free gyroscope in order to understand. Here I have already told that Newton's first law has to be used in this free gyroscope. A body will remain in its state of rest or uniform motion in a straight line unless force is applied to change in it. Next please. And consequently, the spinning mass offers a position of an external force. This is called as gyroscopic inertia. What is gyroscopic inertia? This is spinning mass offers the position of the external force. This is actually called as gyroscopic inertia. A gyroscope rotor maintains the direction of its plane of rotation unless an external force of sufficient amplitude to overcome inertia to apply alter that direction. In addition, the spinning free gyroscope will maintain its position to free space irrespective of any movement, and it's for the supporting gimbals. Here what we are trying to explain what is the gyroscopic inertia. I hope you all understand what is the gyroscopic inertia. Here a gyroscopic rotor maintains the direction of its plane of rotation. Unless an external force of sufficient amplitude to command over the inertia to apply to the direction. Also, from the laws of physics, it is known that the linear momentum of a body in motion is the product of its mass and velocity. In the case of freely spinning wheel, it is more convenient to think in the terms of angular momentum. Here, the laws of physics, we are talking about, we already spoke about Newton's first law and gyroscopic inertia. Here also from the laws of physics, it is known that the linear momentum of a body motion, the product of its mass and velocity. In the case of freely spinning wheel, it is more convenient to think in terms of the angular momentum. This is one picture, the free gyroscope. The gyro spin axis stabilizes irrespective of movement of supporting gimbals. So the angular momentum of a particle spinning about an axis is a linear momentum, and perpendicular to the distance of like precision. What is precision? Precision, it is a term used to describe the movement axis of a gyroscope under the influence of an external force. We need external force to move the equipment so that it is under the influence of an external force. If a force is applied to the rotor by moving one end of this axle, the gyroscope will be displayed at an angle of 90 degrees from the applied force. Assume that a force is applied to rotor in a figure. This is the what I have explained, gyroscopic precision. Next. Here it shows some of the applied forces of the momentum. Next. Gyrocompass. Again, for a gyrocompass, gyroscope. Gyrocompass is also the principle of gyroscope. Gyrocompass is a type of non-magnetic compass which is based on the fast spinning disk and rotation of the earth. Rotation of the earth. It is a type of non-magnetic compass. It's not a magnetic compass. It's a remember, it's a non-magnetic compass which is based on a fast spinning disk and rotation of the earth. Another planetary body is used to explain the universe. So automatically find the geological direction. What you can come to know what is the use of it. It will be automatically find the graphical direction. Although one important component of a gyrocompass is a gyroscope. There are not to be same devices. Gyrocompass is built in the user point of gyroscopic precision, which is a distinctive aspect of general gyroscopic effect. Gyrocompass. What is the uses of a gyrocompass? Gyrocompasses are widely used for navigation on ships because they have two significant advantages. Gyrocompasses are widely used for navigation purposes because they have two significant advantages of magnetic compasses. The true they find true north as determined as earth rotation, which is different from the navigation magnetic north. They are again they are unaffected by the ferromagnetic materials such as ship's steel hull, which is change the magnetic field. Gyrocompass principle. I already explained what is the principle of gyrocompass. Is a gyroscope. Gyroscope is not to be confused with the gyrocompass. It is a spinning wheel mounted on a gimbal so that the wheel's axis is free to orient in any way. When it is spun up to speed with the axis pointing to the same direction due to the law of conservation of the angular momentum, such as we normally maintain the original orientation of a fixed point to the outer space. Since our planet rotates, it appears to be stationary observer to the eye of the gyroscope, so that it will be applied to the gyroscope axis to be complete full rotation every of 24 hours. Next, we will come to such an example of app where it is known as a heading indicator. But it cannot ordinarily used for long-term or marine navigation. The crucial additional what gyrocompass is automatically positioned to the north. In some mechanisms, it results the application of the torque whenever the compass axis is not to be pointing them. One method for uses of a friction to apply the needed torque. The gyroscope and gyrocompass is not completely free to reorientate itself. It is a instance a device to connect to the axis to immerse the viscous fluid. Then viscous fluid then will resist viscous fluid. That fluid will resist reorientation of the axis. This friction force caused by the fluid results to the torque acting to the axis, causing the axis to turn in a direction to orthogonal to the torque along the line of longitude. Once the axis points towards the when the axis points the celestial pole, it will appear to the stationary and won't experience any more frictional forces. This is because true north is only direction in which the gyroscope can remain on the surface on the earth and not to be required to change. This axis orientation considered to be a point of minimum potential energy. This is what theory about gyrocompass. Another more practical method is to be weights of the force axis of the compass to remain horizontal, but otherwise all it is rotated freely within the horizontal plane. In this case, gravity will apply to the torque forcing the compass axis towards true north. Because the weights of the confine, the compass's axis coordinates, but with respect to the earth surface, the compass will appear to stationary and pointing around the earth surface toward the north pole. This is also the explanation regarding about the gyrocompass. Next. Since the gyrocompass north-seeking function depends on the rotation around the axis of the Earth causes torque-induced gyroscopic precession. Precession is already I have explained about the precession. It will not orient itself correctly for a true north. It is moved very fast in east-west direction. Thus, negating the Earth's rotation. However, aircraft commonly the heading indicators or directional gyros which are not gyrocompass and do not position themselves to the north precession, but they periodically align manually to the magnetic north. Next, the gyrocompass. Again, here we can go for a theory of gyrocompass. Gyrocompass is subject to the certain errors. These include like streaming error, where is the rapid changes in the course, the speed and latitude, and for a deviation before the gyro can be resolved. On most of the modern ship, both global positioning system and other navigational aids has to be that of the gyrocompass allowed to the small computer to apply for a correction. Alternatively, the design based on the orthogonal for a fiber optic and ring laser gyros will eliminate these errors. So the depends upon the mechanical parts. Instead, using the principle of optical part difference to determine the rate of rotation. This is how the gyrocompass actually located. Here we can see here the gyro is facing flux gate symbols. Here secondary transmitter, the corrected dial, so variation settings. Here the power supply has to be given synchronous flux gate array, so that here we need a power supply to give for the gyro motor as a flux gate, and this is the one schematic diagram of the compass. Go for rudder angle indicator. What is rudder angle indicator? Here, rudder angle indicator. It is on electrical device fitted on board ship in various locations to indicate the position of rudder at any given time. Rudder indicator is used to indicate the location of the rudder at any given time. Where and all we can locate this rudder. Here we can wheelhouse with illumination and dimmer, and the bridge wings with illumination and dimmer, and engine control room also we can use this rudder angle indicator, and the steering gear system, and the main engine emergency starting platform, and captain's cabins and chief engineer's cabins also we can use this rudder angle indicator to find out the position of the rudder at any given time. See, here you can find out where the rudder is indicator has to be fixed, so that we can easily find out where the rudder moves. These are the synchros and dimmer. These are the equipments, rudder indicators used in olden days and in an onboard ship. This is the I already showed in the first picture that how this is. This is the rudder indicator which will be fixed in a wheelhouse, so that when it indicates one light, so that we can easily find out where the rudder locates. This is the arrangement of an onboard ship. Rudder angle indicator. This is the wing port, and this is the wing starboard side, and here the AC/DC supply has to be given, and the signal calibration box. This is autopilot, steering gear system, and the feedback unit has to be given. Steering gear system. Here the three-phase rudder angle indicator. Yes, this is the dimmer. This indicates, and the signal has to be calibrated into the calibration box, and the steering gear has to be moved where it will be the direction has to be given to the steering gear system, so that it will be moved where the rudder has to exactly, and the power supply 24 volt DC has to be given to the wing starboard side and wing side, so that AC and DC here 11 to 30 volt AC has to be given power supply. This is the steering gear system. Here this is the rudder indicating in a on-board ship. Rudder angle indicator working principle. What is the working principle of the rudder? These devices are actually the AC position indicating motors. I already told the power supply has to be given. These devices actually alternating current position indicating motors consisting essentially of two basic components. What and all two basic components is the stator and the rotor, whether transmitter or receiver. The stator and rotor we can usually call it as a transmitter and or receiver. Figure I already shows it is a simple layout. The laminated stators are moved with three windings connected in the star 120 degree apart. How it will be partitioned 120 degree apart. Head-shaped laminated iron core rotors are moved with a single winding connected. To the same supply. When the rotor positions coincides, the EMFs in the corresponding coils of the transmitter. Once again, I'll tell you that how it will be consists of the stator and rotor, whether it will be transmitter or the receiver, it will be connected 120 degree apart. So the head-shaped laminated core rotors are moved with a single winding connected to the slip rings with both rotors connected to the same supply. When the rotor positions coincides and the EMFs in the corresponding coils of the transmitter and the receiver equal. There is no current flow through the stator windings. When the transmitter rotor is turned, the EMFs induced in two stators will alter, and a current flow the current flow in this place. The interaction of a magnetic fields produce a torque in a receiver rotor tending to bring this ratio into alignment to that of the transmitter. So that synchros must be worked in a rudder angle indicator. So I have already explained what is the global maritime distress and safety systems used in onboard ship and what are all bridge equipments and navigation systems. I have given a brief introduction about that and what is the Gyrocompass, what is the master compass, and what is the use of this in an onboard ship. I am giving more importance for the global maritime distress and safety systems and global positioning system. So I hope you all understand at least the basic concepts about the global maritime distress and safety systems in onboard ship and what are the bridge equipments are used in onboard ship and in detail we'll discuss in the next session.